Hello and welcome back. We're going to be looking at 4.1 polynomials and 4.2 some basic exponent laws. Okay, so we're going to start off talking about some polynomials. Now, if you're following along in the book on page 167, they go through a lot of the terminology that we're going to talk about. They're going to give you definitions for things like constants and variables and decreasing and talking about a lot of those types of words. So those are on page 167 in your book, so I would make sure that you're familiar with all those terms, okay? So we're going to start off here. Okay, it says simplify arranging terms in order of decreasing degrees of x. Then write the degree of the polynomial. So here we have three parts, right? We have to simplify, we have to arrange in terms of the order, and then we have to identify what the degree is. So our first thing is to simplify, so that means we have to combine like terms. So we have a positive 3x here, we have a negative 5x here, so you bring 3x negative 5x, leaves you with a negative 2x. Okay, we have a negative 2x squared, a positive 2x squared, negative 1 positive 2, leaves you with a positive x squared. Then we have a negative 9 and a negative 2, which leaves us with negative 7. Okay, so now we've simplified it down because we've combined those like terms. Now we need to write it in the descending degree of x. So descending, right, from biggest to smallest, because it's getting smaller as it descends. So we have to write this as x squared plus a negative 2x minus 7. Now that could just be written as x squared minus 2x minus 7. Either way is totally acceptable. Now, as far as trying to determine the degree of the polynomial, we have to remember that we look at the degree of each term, and then whichever term has the highest degree, that's the degree of the entire polynomial. So here, each one of these, right, you just have x on them, so it's pretty simple. It's just the exponent of the actual variable. So this would be 2 of this term. The second term would be 1, and the degree of the last term would be 0 because there are no variables in it. Then it's just the biggest one. So 2 is the biggest one, so my degree would be 2. So the two parts to your answer of this type of question is that x squared minus 2x minus 7, and then that the degree is 2. Same thing on the next one, okay? The three parts. Simplify it first. There are no other like terms to x squared y squared, so we just bring that down. Okay, then we have this negative 8x y to the fourth here, and we have this positive 2xy to the fourth over here. So if we bring those together, negative 8, positive 2 leaves us a negative 6xy to the fourth. And then there aren't any other x to the fourth terms, so we're going to bring down the 2x to the fourth. Oops, don't forget about that y. And then plus 5x cubed y cubed. So now that we've simplified it down, it's time for step 2, right? Writing them in descending or decreasing, right, degree of x. So we're going to start off with our x with our highest exponent, which is the 4. So that's 2x to the fourth y, and then plus 5x to the third y to the third, because 3 is next. The next is 2, so plus x squared y squared, and then last would be minus 6x y to the fourth. Now in this one we have multiple variables, so we have to add the exponents to determine the degree of each individual part. So here we have a 4 plus 1, so this is 5. Here we'd have 3 plus 3, which is 6. 2 plus 2, which would be 4. And then remember that's like a 1, so 1 plus 4 is 5. So our degree that's the biggest is 6. So we just write that out. Degree is 6. So again, your final answer would be that entire statement, okay, once it was simplified and written in descending order, and then the degree 6. Now we're going to look at some of the basic adding and subtracting of polynomials. So when we add them together, it's just simply that, right? Negative 3x squared minus 4x plus 9. And then to that we want to add 2x cubed minus 4x squared minus 5. So now, just like before, we're going to first combine like terms and then make sure we have it written in descending order. So we have an x squared here. We do not have an x squared here. We have an x squared, but it's over here. It's not the first term. So we have negative 3x squared, negative 4x squared, but those two can be brought together. So negative 3, negative 4 is negative 7x squared. This 2x cubed is kind of chilling there, so we're just going to bring that down. There are no other x cubed terms. There are no other x terms, so it's just the 4x. And then our constants, we have this constant 9 here, We have a constant negative 5 here. So 9 and negative 5 gives us a constant of 4. Now we want to write these in descending order. So this is going to be 2x to the third minus 7x squared minus 4x plus 4. Now this next one is a little tricky. A lot of people read this and they don't pick up on it right away, right? It says subtract 3x squared plus 4x minus 5 from 2x squared minus 9x plus 7. So we have to take this away from this. So this is really 2x squared minus 9x plus 7 minus 3x squared plus 4x minus 5. Now we have to make sure that we distribute this minus through the entire thing so we don't combine like terms wrong. So I'm going to bring down the 2x squared minus 9x plus 7, and that's going to be minus 3x minus 4x, and then minus the negative is actually plus 5. So at this point, now we can combine like terms. So we have our 2x squared here with a negative 3x squared there, which leaves us with a negative x squared. We have a negative 9x and a negative 4x, which leaves us with a negative 13x. And then last but not least, we have this positive 7 with this positive 5, which leaves us with plus 12. Okay, and then the last problem is really about distribution and then just combining like terms. We have to make sure that we distribute the 2d to both the 3m and the n. So 2 times, well, let's just do it in one step. 2 times 3 is 6dm plus 2dn. And then here I'm going to change it to plus a negative and then distribute a negative 5d just so I make sure I get that negative distributed correctly. So I have a negative 5d times n would be a negative 5dm. Then a negative times a negative gives me a positive. 4 times 5 is 20dn. And then we have this minus 10dm at the end. So now if I want to combine my like terms, I have a positive 6dm, a negative 5dm, and a negative 10dm. So positive 6 and negative 5 leaves us with 1, but then we have to take 10 more away from that. So that's a negative 9dm. And then we have this 2dn along with this 20dn that gives us a positive 22dn. Okay. All right, so now we're going to take a look at 4.2, which is laws of exponents. But before we actually go over these problems, I do want to quick remind you, okay, and this is in the information found on page 175 where they go through all the laws. Okay, but if you have a negative x squared, that's really, say, negative 1 times x squared. So if you put like negative 3 squared in your calculator, it's going to give you a negative 9. Okay, if you want, right, a negative x and it's that quantity squared, then you need to write it that way or put it in your calculator that way. So this is really negative x times negative x, which gives you the positive x squared. So just to differentiate between the two, right? If it's not in the parentheses, then it's the negative of, okay, instead of it being negative x squared. So as we look through our exponent rules, right, if our bases are the same and they're being multiplied, we can add our exponents. Okay, if we have all multiplication inside of parentheses, right, and then it is raised to a power, then we can just take each thing in that parenthesis and raise it to that power. And then if we have a power raised to a power, it's really the same as just the two powers multiplied together. So as we look to simplify here, okay, this is just 5 times 3 times 4 times x to the second times x to the fourth. So we have to remember, right, 5 times 3 is 15 times 4 is 60. And then we have this x times x squared times x to the fourth. So this is really x to the first. So this is 1 plus 2 plus 4. Because the bases are the same, so we just add their exponents. So that's 60x to the 7th. This next one, remember, this is like negative 1 times r squared times r to the fourth, because that squared is not on the outside, it's on the inside. So this is really negative 1 times r to the sixth, because this is, right, we add the exponents, 2 plus 4 is 6. So this is a negative r to the sixth. Okay, number 3, right? We have the exponent on the outside, so that means since it's all multiplication on the inside, we can just simply make each one of these raised to the second power. So 3 to the second power, x to the second power, y to the second power, z to the third to the second power. So 3 squared is just 9, and if you have x squared squared, 2 times 2, because a power to a power is you multiply, and then the y squared just stays that way, and then z we have to the third, oops, that should be squared. So if we have to the third squared, it would be 3 times 2, which is z to the sixth. Okay, a number 4, right, we have to distribute this to each one. So some students like to change this to plus a negative, and I'll show you why here in a second. So this would give us 2pq times p squared plus 2pq times a negative 3pq. Right, so that way it keeps that negative in there, and so some students like it that way. You can leave it as the minus and then leave that as positive 2. It doesn't matter which way you choose. Okay, then we have plus 2pq times 2q squared. So now we just have to go down and simplify each part. So here we only have a 2, so we just leave that as 2. Here we have p to the first, p to the second, so that's multiplication, so you add, so 1 plus 2 is 3, so p to the 3, and then our q. On our next one we have 2 times the negative 3, which is a negative 6, and then p times p, so 1 plus 1 is 2, q times q, 1 plus 1 is 2, and then the next and final one, 2 times 2 is 4, p, there is no q here, so this is just p, and then q to the first times q to the second, 1 plus 2 is 3, so it's q to the third. Guess I didn't box any of my answers on this one, huh? Okay. So then number 5, right, we have this exponent raised to an exponent. So we have to do that first, right, because our order of operations tells us. So we have a to the x minus 4 times, that this has to be multiplied by this. So 2 times x would be 2x, 2 times 2 would be plus 4. So now our bases are the same, so we just have to add the exponents. So that's a to the x minus 4 plus 2x plus 4. Well, we have x plus 2x, so a to the 3x, and then you have minus 4 plus 4, which cancel each other out, so you're just done with a to the 3x. And then finally, number 6. This one is a little tricky in the fact that, right, our bases aren't the same, and all the rules that we went over, our bases have to be the same. The good news is that each one of these can have the same base. So this is really just 3 to the 3n, just like it says. But now 9 is really just 3 squared to the n plus 1. And then on the other side, right, 27 is just 3 to the third power to the n minus 1. So at this point, we just have to use our exponent rules. So this is 3 to the 3n times 3 to the 2n plus 2 equals 3, and then again, exponent, exponent, multiply, just like over here, 3n minus 3. So these two, right, same base, so that means we can add the tops. So 3 to the 3n plus 2n plus 2 has to equal 3 to the 3n minus 3. Well, now we just have a single base that's the same, so now we can just focus on the tops. So 3n plus 2n plus 2 has to equal 3n minus 3. We can then combine 3n and 2n to get 5n plus 2 equals 3n minus 3. Subtract 3n from both sides to get our n's together. Then we'll subtract 2 to get our constants together. So 5n minus 3n is 2n. Those cancel, and we're just left with negative 5. So then if we divide both sides by 2, we get n equals a negative 5 halves. Okay, you'll find your homework right there. Good luck. If you have any questions, just let me know. Have a great day.